Hi everyone, my name is Min, and I want to tell you guys something really interesting that happens to organic pollutants after they enter our environment. So if you guys remember the oil spill that occurred in 2010, put a lot of these polycyclic aromatic hydrocarbons, we call them PAHs, into the environment, and those things are really toxic, right? But as it turns out, UV light degrades these into other compounds that are potentially even more toxic. And so I want to see how those compounds affect the eastern oyster, Crassostrea virginica in this case. So what I'm going to do is I'm going to culture their cells and then subject them to the PAHs, and then also use the UV light to degrade it right away, so then we'll see what happens. Right? Previous experiments with other organic compounds show that the photodegraded version causes most damage. So I expect the same thing to happen with the PAHs as well. And then once I establish the cell culture results, then I'm going to see what different life stages of actual individuals. And then I can go in the environment and see if the oysters in the field exhibit the same physiological symptoms. And then that would really show whether the PAHs are affecting them. So that's what I'm proposing right now, and I'm going to take questions.
So what's the residency time of there's a whole chain of
these things?
Yeah.
Really short. Okay, so like the PAH radicals is, some could be just a few seconds. And then for ketones and aldehydes could be a little bit longer, but we have to produce them on the spot or else they may degrade, right? So those are the things that we want to be produced on the spot so that they can affect the oyster. Otherwise, they're just gonna go directly into carbon dioxide and eventually.
Your in situ measurements, are you going to go look for PAHs in the environment and then find
Yeah.
oysters
So
that you have to go
hopefully,
find the oil spill?
we're actually going to measure the PAHs in the environment and then apply those concentrations to these experiments too, so we get the same amounts.
Are they pretty high concentration in certain areas? They're associated with crude oil, right?
It depends, so like perhaps closer to more activity. So like where cities are and then with the runoff, and also where mining operations occur. So those ones might have more concentration, but then there's other areas offshore be sparse.
Do you plan to simulate a concentration that would be like higher beyond what you see in the field, just as like a, if things get worse in the future?
Probably, but I actually want to avoid that because I actually think that a lot of experiments that project are really kind of like unrealistic because most of the ocean acidification experiments, they just go way beyond what is, obviously there's going to be some sort of effect, right? I'm actually would be way more interested in seeing effects at very small levels because those are realistic, right? If we can produce results from very small levels of change, then good, right? If you can produce results from big levels of change, well, that's obvious. So I probably will, but I'm going to try to stick to background.
Yeah.
Okay, so real quick, I just want to let you guys know that our lab doesn't just work on oysters. We also do zebrafish and snails and human tissue. And besides PAHs, we also work on microplastics. So if you guys are interested in checking that stuff out, then you guys can follow this link to our lab webpage. It's called the Environmental Health Lab.
Final question.